guy.
Microbiology.
Ask him about nitrogen metabolism. He just finished a book on it.
Yes, I just finished a book on nitrogen. How we can remove nitrogen from the wastewater.
Yeah. It's almost done.
Almost done, 95%.
Yeah.
And it will be out in the next week.
Make sure it's plumbed to the wastewater treatment plant. Can you briefly say what kind of work it's done in here?
Yes. You know what? This lab is basically for two purposes mainly. One is to check if the process is going smoothly on each step. You visited influent, then primary clarifier, then it goes to the treating filter, and then goes to the activated sludge. And on each step is a process evaluation there. And also we do whether we are meeting the state and city guidelines, but they have given us the limits, you know. So we check those two. These are two things. And in the wastewater, Mike is looking after all the things, you know, and his job is to remove all the solids, dissolved solids or suspended solids, all kind of solids. It means the water then goes out, it's without any solid. It's clear. So there is a guideline, this is given to us, this is called the permit. And the limits are that we should have over 95% removal of the TSS, which we do. We do better than that. And we check the water of the river. The water we throw in the river is better than the river water actually. And we can further treat it, but not here. We don't. If the water is shortage, and we can further treat in different places. We are doing that. People are using, and we can make it for the use in the homes even. So I hope we will never get to that kind of shortage that we have to do that. And if you have any particular questions, I can answer that.
Do you have any of the plates where you've checked for the coliforms?
Yes, we do.
Can we?
This is the test we do. What we do. This is a filter, or you can say it's a membrane, whatever you call it, and its size is I'm not sure. It's quite, you know, it retains the fecal coliform. And what we do, the media we use is, excuse me, I will show you the media.
So they use a different one than we're going to use. We're going to use Endo Agar. They're using a different one, but it's very similar in purpose.
It's called rosalic acid broth. This is the media we use. What we do, we put it on the petri dish where this, what's called, this membrane will go, and we put this before, and then the fecal coliform, they will grow. We usually use 50 ml, but we have to multiply by 2 to give the answer in 100 ml. So there is a limit we have that we should not go beyond that. And we check Mike's work.
Oh, it's gone. It's gone. Oh, we might have.
Yeah, we should have told you. We have taken it out. These are colonies. They come up, and coliform is the indicator of pollution. You know, you know more than I do, I'm sure. And then we do the other test. There are two tests which are very important. There are the three tests, I would say. One is coliform, the other is BOD, biochemical oxygen demand. How much oxygen will be required to bring it to the equilibrium, and we throw it in the what's called in the river or any receiving water.
Which is basically how much organic material is in it.
That's right.
Yeah.
Is the organic material, the oxygen demand, how much oxygen will be required to utilize to bring it to the, advance to the equilibrium. And this is called BOD. It's a very important test. It gives us, when the water comes in, usually BOD is about 300 milligram per liter. When the water goes out, it's less than 20. Usually it's less than 10, but sometimes it goes up to 20. Very seldom though. Today we got 9 BOD, biochemical oxygen demand, and that test is what we do. Are you interested to see what we do? Okay, this is the BOD test what we do. This is our drinking water. Okay, this is what I did today. I took a sample, used 3 ml, 7 ml, 15 ml, 25 and 50 ml of that sample. And then I checked how much oxygen it has. This is the oxygen it has, 8.55 milligram per liter. This is the oxygen, that was free oxygen. And then I put it in the incubator at 20 centigrade for 5 days. After 5 days I will take it out and I will do the final DO. I will check how much dissolved oxygen is in that, and then I will subtract that. The more the oxygen has been consumed, the more BOD it has. That's the depletion in the DO gives us how much organic matter is there. That is it. And this test was developed in about 200 years back, 1800 something. And we use 5 days. Why we use 5 days? Because this was developed in India, and the guys who were working on this, they found out it takes 5 days to take the water from the river to the sea, or from the. So they start with 5 days, and it is all over the world. We use 5 days as it becomes standard, and also after 5 days, the depletion becomes very low. It doesn't deplete too much. We can do it indefinitely for our experiment, but 5 days is the standard we do. Then we check COD, chemical oxygen demand. Chemical oxygen demand is all the material that can be oxidized in the sample. We do that only for few samples, and that is about 50% higher than BOD. And on the other side, we do TSS, total suspended solids. This one. How much suspended solids are there in the material coming in, and how much suspended solids are there, this is going out of the plant. This is the simple test. We weigh this pad or filter. We weigh it, and then we filter a certain volume of water sample through this, and then we dry it at 103 centigrade for 1 hour minimum, and then we weigh it again and we see how much suspended solids are there. You got it? Alright. And then we do another test, which is called volatile suspended solids or volatile solids. Volatile solids are, we heat a sample, certain volume of a sample, we heat it to 550 centigrade for 1 hour. And then we wait after burning it, for 550. And what happens, the organic matter is gone in the air. And the rest is left is the fixed material or the material which cannot be burned, like some gravel or something like that, which is not burnable. So this is really, we do it to check how much organic matter, especially the bacteria, is there, microorganisms. Since we have to do this is estimation, this is the estimation of the microorganisms in the activated sludge. So we do it, I hope I have some, we have done as well. I could show you the samples and what it looks like. And this test is a volatile acids. Up to C8, C8 means there are 8 carbons, and that is, up to that, the material or oils in the sample, they are volatile, we believe. C10, C9, up to C9. And then we check it how much volatile acids in a sample is. So that is one thing we check. Anything else you want to know, I would like to.
Maybe we should let, some people have classes that they've got to get to, so I want to let people who need to leave, and then anybody who has more questions can continue to hang out, but they can leave through there, right?
Yes. Yeah.
Okay. Thank you all for coming. We'll talk more about it on Monday, Tuesday.